So give it one more minute. And whilst we're there, there is a chat function that you can chat to myself and the host, and also other panelists. And we do actually have a Q&As button as well, where you can ask your questions, and I'll get round to answering them. Feel free to say hello. It'd be nice to know where you're from. That would be good. And ask the questions, and I'll see if I can answer them when we get through this this live demo. So give it another 30 seconds, and I'll crack on. Hi, Ava. A few more people have joined. Right, so I'm going to start. Hello, welcome. My name is Matt Gritt. I am a senior enterprise solution engineer working for Sumo Logic. And over the next few minutes, I'm going to walk through a kind of application observability walkthrough. This will be sort of like a 3 a.m. troubleshooting process for like an on-call engineer. We're going to go step from step from an alert on a service level objective, explore some metrics, use them to help diagnose the problem, look at our traces and identify which surfaces are impacting, and finally look at logs to confirm what the root cause is. So talking about that, Sumo Logic is a centralized information. Regardless of streams, we centralize all the information, regardless if they're metrics, they're traces, or they're logs. So what I'm going to do is I'm going to go through a few slides, and then we'll do a bit of a live demo. There'll be some more slides, and I'll show you a little bit more. So this is going to be our sort of agenda of what's going on. So I'm going to talk to you about service map, traces and spans, and logs, and we might get into global intelligence and Kubernetes if we have time. So what is observability? Well, observability allows you to use your logs, your metrics, and your traces to find out what is going on, where it's going on, and why and how. So a metric will definitely tell you, hey, look, something's happening. You're out of fuel, okay? The logs, if you go into the logs and you search through the logs, you'll be able to find out what the reason is. And then with the traces and the metrics, that sort of tells you when and where it happened. So that's why we sort of pull all of these together to give you that sort of continuous, intelligent view over the whole of the operations of your entire stack. With that, how does this all work? So we are able to collect information from a myriad of sources, be they on-prem or in the cloud. It doesn't make any difference to us. I've been working for the company now for just over 3 years, and there's not been a system that I've not been able to get data or information out of. We can pull this from, AWS, GCP, Google Cloud Platform, Azure, whatever you want, as well as your installed devices, on-prem things, etc. So what is about Sumo Logic Observability? Well, as you can see, it's built for observers. It's all about the visualization and being able to explore what you need to do. We can apply some analytics to it, and then we can do some benchmarking. So it's built for observers. We work with our clients, with people like yourselves, to make a very friendly UX visualizations, making it really easy to onboard. And we have a lot of out-of-the-box integrations. These are set up with dashboards out of the box, alerts out of the box for you to just basically hook up and just use. Our systems, if they hook up and you're using like microservices, we're quite capable of doing auto discovery, because modern web applications change so much. Modern applications are based on ephemeral things. So we need to be able to capture those logs and things and metrics and traces and pull it all together. So because we're pulling all of that together, we can analyze that in real time and give you, visualizations, and you can see the dependencies and what's going on. So it helps you to investigate faster. the way we've set it up, and I'll show you this a bit later, we try and make it very intuitive to be able to do those drill downs and sort of get more sort of in-depth to help you with those troubleshootings. And because we're sort of a fully continuous intelligence platform, we do have a lot of machine learning algorithms running over these systems and the data to show you things like outliers, to show you things where there might be an easier way to sort of pattern match, and we'll get into that as well. And then lastly, with the sort of like the benchmarking and optimization, that's where we can see how your systems compare to typical systems that we've got data on, to see where we can make recommendations to you so that you can make your systems work more efficiently. So I'm going to go into a bit of a live demo, and we're going to talk about a few little things. So in this live demo, I'm going to say that I'm an on-call engineer for a banking application that basically runs on Kubernetes and AWS. We've got our load balancers, we've got a payment service, and then it goes into our deployments of our various pods and things that then go down into our account service, and then eventually down to our database, our RDS database. So all of these services are mission critical, and they run at all of our banking locations. So I kind of get an email alert around about 3 a.m. And Sumo Logic is notifying me that there is an issue with our banking application. So this is a typical sort of alert that you might get for, say, something like PagerDuty or something. So one of the things it tells you a little bit about this, and it gives us a link. So if I was to click on this link, it would take us into straight into our system. So I've got this set up for us here. The link basically lands me right at the Sumo Logic panel, what's created the alert, looking at the service level objective violation in the right time frame that we were looking at. So if I click that link, it would take us here, and it would give us this precise information. So some of the things that we can show you, see, you've got the maximum error rate. So this is probably something that is triggered off. We've set an alert to say, hey, if our error rate goes above this particular level, send us a notification. Send it, we're monitoring that. So here we can see that we have a panel that is showing us the error rate over time. So this is our timeline along the bottom. The blue line is our actual data. The pink cloud is what statistically the values that we expect based on previous data points. Now, you can see that there's these little pink dots, and the blue line is outside that pink cloud. So that's basically saying that, hey, we are getting results that are statistically outside what we expect. And these are the things that we can set up to trigger alerts, and these are the kind of things that we would use for notifications. So some of the most critical information on what happens is who's affected by this particular, what customers are affected. So some of the things that we can do is we can actually look at the customer IDs that are affected, and reach out to our customer support teams, identifying who it is that they need to talk to, and allowing them to get on with their job and tell them of what's happening, and to support those customers. We can see what the errors are, and this could be some information that we want to share with our customer IDs, or it might be help us to identify what's going on. We've also got data on the transaction volumes that we're expecting to see, the drop where it's affecting us, and we've also done this is on a particular amount of dollars transferred in our system. So you can see a very similar kind of curve. And then we get down to our error rate by pods. So not like, as I said, we're running in Kubernetes, so each one of these pods is running our services. And this honeycomb view allows us to see all of the pods that are running and their current error rate states. So as you can see here, we've got some that are green, and these are kind of running at an error rate that we feel is okay. We can see that we've got some yellows, which are obviously running at a slightly higher error rate. And again, we think this is okay, but we want to keep an eye on it. And then you'll see that we've got a lot of these pods that are running with a very high error rate. So what we could do is we could actually look in maybe one of these pods. You can see we can click on it, and it pulls up a little bit of summary of the value we're expecting. And then we can go and have a look at the entities, and it will pull in information that we have about this particular thing. We can see the CPU usage and the memory that it's using. And we can see, what it's a part of. So all of the data that comes into our system is enriched. What we tend to do, we get the data in, we give it, enrich it with some metadata, talking about pods and services and deployments, etc. So we've got some context about where the logs are coming from, where the traces are coming from, and where the spans and the metrics are coming from. So I want to sort of show you that there's a lot of errors across all of the pods. So this is probably something that is a more of a consistent problem as opposed to one pod failing or something like that. There could be something else going on. So what we want to do is to basically drill down into what's maybe happening. So one of the best ways we can do that is, because we have traces and spans, we can open up a service map. So I'm just going to go and do that now. I'm going to click on this. I'm going to go down to service map. And I'm just going to bring it to our default application. So we can see here that we have our payment service here, and we can see that goes to our transaction service, and it also goes to our account service. So we can see that we've got some information and errors here. We can also have a look at the accounts, and again, we can see that there's a little red line around that indicating that there are anomalies. We can see that there's a latency. We can see the requests that are coming in. We can see that it's below average. Maybe something's going on there, and we can see it's got an error rate. If we click on it, again, we get that sort of entity information coming out. So we can see that it's the latency, the requests, error percentage per second, etc. And we can see that it's in this particular our application. So we can interrogate these further if you wanted to, and you can go in and see what's going on. So one of the things that we might want to do is, because we're in the accounts, we might want to open this up and see all of the traces that are happening for this time period on that account. So I'm just going to click on traces, and it's opening it up. So these are all the traces that are coming in for this particular application and this particular service in that application. Now I'm going to filter this, and what I'm going to do is I'm going to filter this with number of errors. I'm going to say, hey, I want to see all of the spans that have more than 5 errors, for instance. So it's bringing back that data. So you can see that we have a trace. We can see what the root service is. We can see what the root operation was. So this is a payment transaction. Start time, how long the duration was, number of spans, a kind of breakdown of what services were called in that trace, number of errors, and what the status is. So this is a 500 error. So this can give us a very quick glance of all the traces and what's going on. Now we might want to dig deeper into this problem and actually click into the trace and see the spans that are in that. So I'm just going to click on one and go into this. So this is a span view. So this is showing us the total length of time that this transaction took. It's giving us an overview of how long each part took. So the accounts part took up around about 30 seconds of the whole thing. And the payment part took up like 1 second. And you can see that the various different spans of this trace. Now these are kind of, we call them icicles because they go down to a smaller instance. And it's basically a sequential kind of thing. So if we actually just hide the service names, you'll notice that all of these have a red line across the top, which means that they contain errors. Now the ones at the bottom, the lowest ones, if they contain the error, that's probably going to bubble up through the entire system. So let's go down and have a look at this particular service. We can click on it, and we can find some information about it. So we know what span it is, the trace ID, the service, what the actual operation is, CRUD repository find by ID. We can see the start time, end time, etc. we can go into some metadata. So all of our spans and traces and have metadata associated with it. So we can see what the application is, we can see what Kubernetes information we have about it, etc. So we can see that this is our account service in our deployment in our namespaces. We can also go into the entities and find a little bit more about them. So we can see that it sort of comes from the account service. This is probably one that we might want to have a look at. So this is a container that contains those pods. So what I'm going to do is just open this up a little bit. We can see, again, we still have sort of entity data about CPU and memory usage and things. And then what we can do is we could say, hey, I want to look at all of the logs that are associated with that container that are involved in this trace. So I'm just going to go onto log search. So this is bringing up, one of our typical log searches. We can see that this is pulling in the data to say, hey, look, in that particular time range, this is the container, this is the pod that was having it, and the namespace and the cluster. So these are bringing back the actual results. So you can see that they brought back around about 260 lines, actual log lines. Now, your systems might be producing a lot more than this, but one of the things that we can do is, instead of having to look through each one of these log lines and see what's going on, we have these two really, really cool features, log reduce and log compare. I'm going to show you log reduce at the moment. It's one of my favorite buttons. You click on it, and what it does is it will go through all of the logs that you've brought back, and some machine learning algorithms will basically pattern match it. It will check it against all the other logs and see how many of each type that we have. So with that, we can see that out of those 260 log lines that we had, we can see that we've got a certain amount of each one. So this means that we can really, really see quickly what's happening, in those logs. So we can see that this one looks like it's, a problem. That we can see that it's an error. We can see that it appears to be they could not open a JPA entity manager for transaction. We look down, and basically it's saying that it's unable to connect to a database because it has basically too many connections. So from going from our initial sort of email that we got or notification that we got, we've been able to go through quite quickly, see that it's lots of pods are being affected. We've been able to use a service map to track down what's happening in the account in the particular services. We've used the traces to see what's going on those particular traces. We've dived down into the span views to have a look at what's the root cause of those particular issues. And then we've gone and looked at the logs and used our log reduce function to basically give us a really good idea of what's the probable smoking gun. So me, as this 3 a.m. Engineer, I come in here, I look at this, and I go, right, there's not enough connections to that particular database. Maybe we need to go back, change some configurations. And when we did those configurations and put them back in our sort of Kubernetes, we would definitely see those changes cascade back, and we'd see that our service level objectives would be met. We can see that those pods would eventually turn back to being green, and we would have solved the problem, and we'd have gone back to work, business as normal. So that's what I've got for that sort of easy application troubleshooting. But I want to show you, some other things that we can do. So I'm just going to go back to our slides, and I'm going to talk about global intelligence. Now, we have a lot of out-of-the-box apps that we call global intelligence. So this is just one. This is just Kubernetes, but we have it for others. We have it for AWS and a few NGOs and a few others that we can have a look at. And they're all available in the app catalog, which is a part of our default system. I'll just show you that that's in our main menu. They're all in our app catalog. If I just go down to global intelligence, you can see that we've got quite a few here. And basically what they allow us to do is allow us to take a look at the metadata that you're producing, compare your results with those that we have data for, and make recommendations upon what is probably the best thing for your particular Kubernetes or your Apache. Because going back to our business problem, we were looking at the load balance of the payment services, the deployments, and the account services, and then the database. We have this thing where if you're in things like Kubernetes, you might have to provision your CPU usage and your memory usage, and you've got to basically say, look, what is the limit, and what are the requests coming in, and if you sort of put the limit too high, you're spending money and wasting it because you never reach that limit. You might be under provisioning it, where you've brought it down, but actually your services use a lot more memory or a lot more CPU than you expect, and it gets over that limit, and because it goes over that limit, you start to go, nope, it's got too much memory, and the pod that it's running on, that service gets killed, and you have issues there. So with a lot of this, we've basically taken all of the sort of the data that we've got, and basically we've had a look through it, and we can say that customers, they under provision their containers, and that you have risks there of costs, or they under provision, and then you've got risks of outages and failures. So we've noticed that out of all of the containers that we've ever monitored, around about 80% of the containers are unoptimized for CPU, and and 86% are unoptimized for memory. So if you're using Kubernetes or some of the other services, this is where we start to get real useful information to you for you to do things. So we can see that setting up the 4 parameters, the container CPU and memory and the request limit, we can, if you wanted to try and do that manually, it's near impossible, but because you just have to keep tweaking everything. So what we kind of do is we give you some values that you can use, and what we try and do is we try and put you in that sort of sweet pot, that area where you can say, actually, I really want to be sort of cost optimized, or I want to be reliability optimized, or I just want to be balanced. So that's where we kind of try and get you into a sweet spot that works for you and your company. So what we basically do is we are getting information from 17 million containers. That's kind of how many containers that we are monitoring currently. And we've been monitoring them since mid-November 2020. We get all of that information, and we use it to make comparisons against your data and the data that you are providing us. And we have dashboards for these. These are out-of-the-box dashboards, and I'll show you them in a minute, that will be able to see these things where you can go in and have a look, and you can see the recommendations. Oh, I will jump in now back to my trusty demo environment, and I'm going to show you where you can see these. So we're going to go in here, we're going to go into Explore, and we're in the Kubernetes deployment view. There are others, but I'm just going to show you the deployment view. I'm going to go back into our demo environment. I'm going to go down to that mobile banking app that I sort of showed you. And I'm going to go to that service deployment, and you're going to see what's been going on there. So again, this is pulling in live data right now from our demo environment. We can see what's running, etc. And I've kind of shown you that previously. You can see what pods are having problems with. But one of the things I want to show you is the optimization. This is one of the Kubernetes deployments optimizations. So obviously there's a little bit of information about it. It talks about risk percentages in Slack. It talks about container information. I'm just going to do this for our demo purposes. So what this is basically doing, it's saying, hey, this is our how much Slack we have in our container memory, and what the kind of risk is at the moment where we are. And then we can go back and we can have a look at the various different types of risk that we're talking about. So if you want to be a cost optimized, That's this particular column. If you want to be a balanced optimized, it's this column. And if you want to have reliability, it's this column. So you can look at the various, what is actually there from a memory perspective. And then we can do exactly the same with the CPU. We can see, what's your CPU from all of those things. What is it like in a cost optimized view or a balanced view or reliability view? So this gives you kind of a bit of information, a good way of sort of checking what's going on. The metrics are coming back to show you that, hey, you're about there. Now, one of the other things that we have is we have the details of this. So this is where we can actually go in and start to say, hey, let's go and have a look at some of the details and give you some recommendations. So again, you can come in, you can see, green is okay, yellow is, you might want to have a look at it, and red is, hey, you should, maybe have, what's going on. So you can see here, it's a little bit more, what's going on, how you want to do it, again, for memory and CPU. But one of the things I really want to show you is our recommendations. So we come down here and we look at the request recommendations for memory and CPU. So you can use these values and feed that back into your Kubernetes configuration files and actually have something that's, making sure that you are in that sweet spot where you are not over provisioning and wasting money or under provisioning and causing outages and errors and all sorts of other nastiness that you don't want. So you can do that with the request recommendations for memory and CPU. And we also, when it comes up, have that for the memory and the CPU cores as well. So not for the request limit and the limit recommendations. So you can take those values, feed it back into your Kubernetes configuration files, make the changes, and then you'll be running on a more leaner, more cost-effective, hopefully more risk adverse or container setup. So you won't have some of these problems. You won't get these kind of errors because you actually have the data to make sure that your pods and containers are working correctly. So that's it in a sort of a nutshell. I'm open to questions, and if anybody's got any chats, that would be really good. I know we've only got a few minutes left, but if you have any questions, please ask them. If not, reach out to me. My name is Matt, and it's Matt Gritt, and you can email me on Matt with one T, M-A-T, at sumologic.com. Or if you're part of our Slack, slack.sumologic.com, you can join that for free. And then you have access to people like myself, other customers, and you can ask them questions as well. And if you're not familiar with Sumo Logic, you can actually start a free trial. It has virtually everything turned on for you. You just need to set it up. It's free for 30 days. And it's available at sumologic.com/sign-up. And if you want to sign up in Sydney, then it's /AU. Thank you very much. I hope you've enjoyed it.